So now to finish this question, we're putting a third wire at point P. That's got a current flowing into the page, and we want to find the force per unit length on this third wire. So let's take stock of what we have. Just do a quick sketch of the picture again, because that one's getting a little bit busy. Here's our point P right here. We're putting a wire with a current flowing into the page, so we've got a current carrying wire right there. The magnetic field at this point is the net magnetic field. It has an X component and a Y component. So there's the X component, there's the Y component. So the net magnetic field points this way. Because there's a current carrying wire in a magnetic field, it's going to feel a magnetic force. So let's see if we can figure out what that magnetic force is. Let's do the direction first. We'll use the right-hand rule. The right-hand rule says we know that magnetic force equals IL cross B. Okay, and then, so to get our direction, we point our thumb in the direction of the length, which is the direction of the current, so into the page. And then our finger goes with B, and then our middle finger sticks out to show our force. So it's going to be perpendicular to our B and comes up this way on the page. So our force comes out this way. So this force and this magnetic field are perpendicular. Those are right angles. There's two ways we can find the force. We can put in our magnetic field that we found up here, and we can do the cross product, or we can do magnitude and direction. Let's do magnitude and direction. Because we're pretty close to having the direction already. So the angle for our net magnetic field right here we can find from our X and Y components. So tan theta is the Y component over the X component. So theta is going to be the inverse tan of the Y component, 3.49 times 10 to the minus 6, divided by the X component, 0.755 times 10 to the minus 6. Let's see what that gives us. Inverse tan 3.49 divided by 0.755. That gives us an angle of 77.8 degrees. That's this angle. So now, since these two guys are perpendicular, then this angle plus this angle must be 90 degrees. So the angle in right here will be 90 minus 77.8, 12.2 degrees. So now we have the angle for our force. Let's go ahead and find the magnitude. So the magnitude of our force is IL times B, times the sine of the angle between L and B, which is 90 degrees. We're asked for the force per unit length, so F over L is I times B. I is the easy part. I is the current in the wire, that's 2 amps. B is the magnitude of the net force. The magnitude of the net force we can find from the components. So that's equal to the square root of minus 0.755 times 10 to the minus 6 squared plus minus 3.49 times 10 to the minus 6 squared. Can put that through the calculator. 0.755 x squared plus 3.49 squared square root gives us 3.57 times 10 to the minus 6 teslas. Then we multiply that by the current, 2 amps, to get a force per unit length of 7.14 times 10 to the minus 6 newtons. And then we want to write down our answer as a vector, so the force per unit length is 7.14 times 10 to the minus 6 newtons at 12.2 degrees above the negative x-axis. So there's our net magnetic field and our force on that wire.